So there should be an admit button in the participants.
Let me check.
Okay, so maybe I just disable the waiting room so that people can join directly. Okay, all right. So all right. Okay, so now you can mute it. You can mute yourself. All right. So hello everybody. So welcome to the engineering all hands of GINA AI. So this is actually the actually we have this as an internal meeting. We answer all the questions from the engineers regarding all the hardcore engineering problems, but later we decide to make it public. Right? So you can see you can join in as external contributors, or if you just have interest or you want to know how to solve a particular problem, or what are we planning on particular issues. So this is what you can expect it from this conference, from this meeting. All right. And the other thing is we are also streaming this on YouTube, and later we will also upload the recorded version and to our YouTube channel. All right. Okay, so without further ado, so let's get started. As I said, the purpose of this all hands is we basically want to build an open governance model. Let me just make this full screen. Open governance model around GINA because we are open source software company, right? So, and I write this in my blog, but I also mention this point in many places, that open source is not only about uploading your source code to GitHub. While the most challenging part is the building a sustainable, let's say, open governance model, which is transparent to the community, but meanwhile is efficient in terms of the dev cycle. Right? So you still want to iterate very fast, but meanwhile you want to keep the community engaged and also have the external contributors keep in the loop, right? And so this is super important because this is part of our engineering culture, and we really want to make it right from the day one. All right. So I mean, unlike the other meetups and conference, right? So in this meeting, so I will basically serve as so you can imagine this is a pure question and answer session, right? So I'm going to answer all the engineering questions from your side. And so I ask you to prepare, especially from the in-house developer, in-house engineers, to prepare the questions for me, right? And those questions that I really like is, for example, why is this API implemented this way, right? Or is there you found a set of code, a particular part of the code where you found a way to optimize it, right? Or you are not sure about your implementation is really the most efficient way, or the most follow the best practice that we defined as company, right? So see there. Okay. So these are the questions that I really like, and for the engineers, especially for the in-house engineers, if you haven't read because right now in this month we have multiple engineers on board this month. So if you haven't read this engineering onboarding guide, please do. Right. So it also defines specify what are the do's and don'ts when working working in an open source company. This is quite different compared to your previous experience where probably they are open. Most likely they are closed source, right? So there are some do's and don'ts, and so please read this guide carefully, right? Okay, so now we comes to the question. So do we have any questions from in-house engineering right now? From the in-house team? Nan, can you yes.
I have one, Han.
Yeah, John, yeah, please.
Yes, I have a question about the design principle what was the idea of letting such a big flexibility in relating drivers and executors, because I sometimes find it a little bit, I find I have too much freedom, and that can become sometimes a source for errors or harder to find the right way to do it.
Yeah. Okay. So this question is about why do we have the driver? Why do we distinguish the driver from the executor, right?
No, I
And why do
understand this distinction, like so much freedom, so much.
Yeah. Yes, exactly. Yeah, so basically, so let me explain this from the what the story begins, where the story begins, right? So initially we have this, so probably some of you know my previous project Genus, right? So in the old project Genus, we don't have this kind of executor driver P, this kind of P part, this kind of abstraction. So everybody is called one thing, they call service, right? So we call them service, right? So we don't have this, everything is very coupled together. But in Gina, we decided, or I decided to decouple this thing from the very beginning, because executor is something that really aimed to the AI engineers. So it's not aimed to network, to the backend engineers. Right? So if you work on some executor, right, the developer experience for you should be, you just focus on your AI algorithm. You just focus on your, this kind of hardcore state-of-the-art algorithm. You don't worry about how the communication goes and how to read protobuf, this kind of thing, right? As long as you know NumPy, right? You know how to manipulate NumPy array. You know your favorite deep learning libraries such as TensorFlow, PyTorch, or whatever, right? And that's it. That's the job. With that skills, you can already implement a very good executor, right? Can be used in other places. Right? And the reason that why we let's say we decouple the driver from the executor is that initially the executor has the ability to manipulate or to read and write from or to the protobuf, right? And we realize that this part of the thing should not be worried by the AI engineer, right? And also this is not part of their job, right? So that's why we have the driver separated from the executor. By separating the driver from the executor, you can put all the protobuf manipulation into the driver, right? And so the driver is working as a translation layer, between the executor and the protobuf. Right? And so that you can also, let's say, play in a more advanced way. So you can also implement the driver in Python or in pure C, right? And then use Python to load this C implementation to make the driver more efficient. Because in driver, most of the operation is around the protobuf, right? And you don't necessarily need Python to manipulate the protobuf. You can use C, you can use Python, PyPy, or whatever, right? And so this is our original intention of using separating the executor and driver. But the reason that why you see so much flexibility in the driver or in the executor or in their combination is that right now you are working on so executor and driver, especially this driver, it is very low level, right? It is, I mean, if we see Gina as a framework, right, then the driver is pretty low level, right? And so the reason, and you are working on this very low level layer, right? So that's why you see a lot of flexibility. This is very natural, but we are not intent to expose all those flexibility to the developers, right? So this is something I want to emphasize. So this is as a developer for the framework, you are exposed to the to the greatest flexibility, but it is actually your duty to somehow abstract from those flexibility and provide a more concise API, a more user-friendly API to the other developers, right? So what I imagine is that executor, so people can add a lot of executor to Gina, right? But we don't expect them to change a lot of things on the driver side, right? Because the driver is let's say it's just let's say it's more boring than the executor part because it's all about protobuf manipulation, right? And so, but all in all, you will observe this kind of flexibility, right? So it's overwhelming, right? When you develop a GINA, when you're developing GINA as a framework, right? But this is also understandable. Imagine that, for example, you as a low-level developer of the TensorFlow, right? You of course are facing all this kind of flexibility every day. But at the end of the day, right? People who use TensorFlow, they are using high-level API or intermediate-level API, right? They are not exposed to the low-level API, right? And so that's basically the answer. Yeah.
Thanks.
Yeah. All right. Any other questions?
Yeah, I have
next
a question.
Yeah, please.
So I'm wondering what kind of external controls are available in GINA once an instance is running. For example, if you wanted to change the flow and stopping the flow, what kind of, are there APIs that are available within GINA to be able to manipulate those options?
So right now we don't have any APIs, right? So once it is running, then it is, we don't have any way to, let's say, manipulate the workflow anymore, right? And so right now we are building, so inside GINA, we have a lot of APIs that provides one-way communications, right? So this basically means that we want to export a lot of information, as much information as possible to the outside, right? So we provide a REST API, and so that you can use GET, right, to fetch the status of the running instance, right? And so this is something that we have right now. But in order to, let's say, if you want to use something like a put, right, this kind of request, or some requests that want to modify the workflow, or some requests that want to change how GINA behaves in the runtime, right? So there's nothing available there, right? But we do have a very basic one, is shutting down GINA. We have this API, right? So this is basically by, for example, if you go to, okay, so maybe I need to reshare the screen because I just stop share and then share this again. So here you can so basically if you clear this thing, you go to GINA Hub and GINA there is a ping, right? So there is a ping command. So this is basically using the control port of each P or pod, right? So you can basically ping an IP address and see what is the response here. But let me check. Maybe this is through gRPC. It's not through a REST gateway, right? So this is through gRPC request, right? It's not through HTTP request. And from the HTTP side, I think we don't have many exposed, let's say, APIs to control GINA. So, and also internally, we only have two, let's say, two methods that you can control GINA. One is via ping, right? So this is via control port. You can send a control command, and you can also terminate. And this is also how we internally ask all the P pods to shut down itself once the flow is terminated, right? So these are the two APIs we have. So you can also look at the proto. Let me check. If you look at the proto here, right? No. proto, yeah, this one. Okay, so if you look at the proto, there is a control request, right? So you see there are basically there's 3 commands, right? So these are the commands that Gina accept right now from the outside, right? So you can basically start from any machine, right? Just send a control request via gRPC and tell that, okay, I want to terminate you, right? Terminate this whatever ppods on this machine, right? And it will shut down itself, right? And also you can get the status of a ppod, right? Yeah. So this is currently the only way to interact with Gina right now from the outside. Yeah.
Okay, I see. And then in the future, are there plans to add more control, or would that more be up to the developer to?
I would, yeah, of course we will add more control. But I'm thinking whether do we need to really put that into Gina core, or do we make another proxy, right? And so basically this proxy is super powerful. It's like a middleman. So you send all the control requests to this middleman, and this middleman basically check all the security compliance and all whatever this kind of access compliance, and then tell Gina to do whatever you request, right? And so there is another thing very interesting is that I think you can also Gina Gateway, right? So there is also one way to spawn new Gina instance remotely, right? So if you check the Gina Gateway, so there is a command, there is an option called Gina Gateway allow spawn, right? Okay. You see, so once you start with this command, so it's basically start a gateway, right? And this gateway basically, then there is a red alert here, say that, oh, security compliance, and this gateway allows spawn requests from remote Gina. So what does that mean? So that means if I'm not sure whether I can demonstrate it here. So split vertical, okay. So let's say I want to, so let's come to, let's say I want to spawn a new pod locally, right? Just assume that, you know, the left and the right panel are different machines, right? So now let me check. So I want to host as itself. I think I don't need to write host. gRPC port, or what is the port?
Port expose.
Okay, so port gRPC and then 51. Okay, so let's see. So this is number. This is a port number described here, right? And do I have any other option regarding the host? No. So maybe just 0.0.0.0. Let me check. So control entry point, port expose, port gRPC. Okay, I have to raise a doc. I forgot how to start this thing. So but basically you can, let's see if there is a port log remote, turn on remote logging, and port expose. And by default it's 0. Okay. Okay, so if I Okay, I forgot how to, maybe, okay, maybe just write in this way, right? Yes, now I see, right? Because, okay, so I remember now, right? So basically write a heuristic, basically check whether the host is 0.0.0.0, and if it is, right, then we basically assume that you're always running on locally, right? And if it is not, then we basically assume that you are running, you want to run this part remotely, right? And here we go, right? So you see that, so basically, okay, so you basically see that, so on the right hand side, on the left hand side, so you see there is it receive a whatever, it receive a setup socket, this kind of thing. So basically, it receive a spawn request asking this gateway to spawn a part, right, on this machine, right? And then you see there is a small globe, this globe emoji in front of each, in front of each line of logs, right? So this is basically an indicator that this part is running remotely, right? And of course, you realize that this is pretty insecure, right? So everybody can, so if you open this to public, that means everybody can, spawn whatever part remotely. But it's a very good feature, right? It's a very good feature, and we actually use that in GINA Flow to distribute the workflow on multiple instances, right? So, and also if you shut down, right? So let's say if I shut down this thing, right? If I shut down this instance, and then you see that, okay, so this one receives terminate signal, right? And of course, because everything here happens actually, all the logs here are actually mirrored from this instance, from the left instance, right? Okay, so to wrap up, right? So we have a way to spawn a new instance, spawn a new P-part remotely, and we have a way to terminate the P-part remotely, and we have a way to check the status, to ping the P-part remotely, right? So these are the only 3 interactions that we have right now. And regarding whether we want to add new options, new interactions, yes. And but we have to think whether we want to build this kind of very sophisticated remote control stuff inside GINA core, or we want to do this, separately as a plugin or something. Right. All right. Okay, so next question.
Well, actually, I have a related question to last one. So, because sometimes the pod in the flow just breaks down, right? And then we need to notify the neighbors about the changes. What happens in that pod? And I was wondering, do we have plan to have some kind of master node that is responsible for creating, deleting, and do some healthy checking for all the pod?
No, the answer is no, right? And the reason is that, so if you notice, if you look at the P-part, the implementation of P-part, and also the design principle of P-parts, right? Health check on P-part from a master node, right? So if you look at the implementation of P-part, you realize that so they are basically doing something called decentralizing the model, right? So that means, so first of all, each P-part is stateless. It's almost stateless, right? It only has one input and one output. So that means each P-part, they don't care about whatever neighbors inside this floor or inside in the same topology. They don't care, right? They don't care. They only care of their input, what they receive, and they care about where they should send the result, right? So by designing the P part, of course, we also have a one part exposed for the control request, so that you can basically use your master node to send control requests to shut down or to do the health check, right? And but by designing by decentralize the P part in this way, right? We gain a lot of scalability, right? So you can imagine this P part, each P part is basically, they are stateless. They only care about their own input as their own output. They don't care about whatever neighbors in the upstream or downstream, right? And so only designing this way, we can concatenate P part, we can build a flow in arbitrary scale, right? And so regarding your health check, right? We don't consider a master node, right? So we consider there should be a context manager, right? There should be a context manager who regularly send health check signal to all the P parts, right? It's kind of like broadcast or publish, right? Publish a health check signal to all the P parts inside this flow, right? And who is managing all this, let's say the registration and the P parts IP address registration? It is a context manager's duty, right? And who is a context manager right now? It is our GINA flow, right? So this flow API serves as a context manager to manage all the P parts, right? And so of course you can add something in the flow API, right? You can start a new thread, and in this thread you regularly send you regularly send the status, right? You send a status signal to everybody, right? To everybody that you know, right? You know that you are in control because you spawn them, right? You spawn them. You as a flow API, you are context manager, and you spawn all those P parts. Of course, you know where they are come from, right? Where they are located. But if you are asking each P part to know the global picture, to see the global picture, unfortunately, this is not our scope, right? This is out of our scope because this violates our decentralized principle in the P part, right? The decentralized principle says that each P part should not care about whatever, the global picture. They only care about the input and output, right? And that's it, right? So my answer to that question is we have a flow API which can do that. You can also implement that in the flow API, right? But I think that this is, but don't put your don't bet on flow API, right? And the flow API is right now is a very it's not like a 100% solid context manager. It's not compared to Kubernetes, compared to Docker Swarm, right? Flow API is an orchestration layer, but it's let's say it's a toy. It's a toy orchestration layer, right? So we have a more mature solution. We can build this context manager. We can build health check on top of Kubernetes, on top of Docker Swarm. Of course, we can also build inside Flow API, right? But we have to understand the scope, and we have to understand other possibilities from even high level API, right? All right. So other questions?
Actually, I've got a question.
Yeah.
Actually, my question is related to what Nan has asked, because you have mentioned the context manager, which will control, which is also the flow, and it could control the whole P and the pods kind of things. And my question is that what if the mini services that the P or the pods gives, and when it encounters fatal problems, could the context manager handle that problem, or should we just use some manual scripts to start the mini services to start up?
Okay, so basically, the thing is that fault tolerance, this is non-trivial, heart beating, I see there are some external contributors say that do we want to implement heartbeat, right, in the Flow API, right? And but unfortunately, heartbeat is no trivial, right? So if we look at the 0MQ document, there is a multiple design principle, or let's say design pattern behind heartbeating, right? And so this is non-trivial. And also regarding the fault tolerance, right? Regarding the reboot strategy, there are a lot of reboot strategy. Let's say you can say you can set alert, say once the memory across some threshold, beyond some threshold, then we basically shut down and reboot, right? Reboot this P-part, right? And so previously we had this option, right? It's called, I think right now we still have, but it's just a raise alert. So let's say GINA part. So we have this called memory HWM, right? So we have this option called memory high watermark, right? So this basically tells the P-part to monitor its memory usage, right, from time to time, right? And once it's beyond that threshold, right, it shut down itself, or you want to do whatever, you can add a callback, right, to do whatever you want, right? And but I would say this is one of the very high level feature that it will be used in production, but right now it's not, let's say it's not urgent to implement that. So for the two reasons. So the first reason is that this is pretty high level, and we are right now still in very low level. And the second reason is that there are a lot of other mature solutions out of the box, right? So for example, in Docker Swarm, in Docker container, there are health checks, there are reboot strategy. In Kubernetes, there are also some. And so that's why we can, as again, it's the same thing as my answer to Nan's question, right? We can of course implement all of that in the Flow API, right? But at the end of the day, is that really worth it, right? Or do we want to really build on top of the other solution, right? And my recommendation is first, my recommendation is not try to rebuild the whales, right? To always try to build on top of other solutions, right? Yeah. All right. Next question.
So any questions from the community?
I've got one. This is Alex, Gina's open source evangelist.
Yeah, Alex is speaking. Yeah.
So users often ask for features that may be completely out of scope for us. And I'm wondering what they've asked for before, or what they commonly ask for, and how we can explain why they're not in our scope. Because when I'm meeting new users, I want to be able to work with them in this way.
Sorry, can you repeat the question again? I think your sound is a little bit noisy.
Can you hear me better now? Hello?
Yes, yes, I can hear you. Okay, so you typed in the. I got a question about the engineering team, but they are more about the interface with DevRel. Not sure if.
Yeah, I can ask in Slack or in another meeting if that's more relevant.
No, I just cannot hear you clearly. So what was your question again?
So what are some of the common out-of-scope items that users often expect or ask for with GINA? And how can we explain the rationale for them being out of scope? Maybe like the top one or two.
How can we explain the rationale for what?
I'll post to the chat, hang on.
Okay. What are the someone called of outspoken items that users ask for, and what are the rationale? Yeah, do we have for them? Okay, so this is about. So auto-scope, so for example, so one frequent question that I always, or one frequent request I always ask by the community is that can we use GINA for classification or clustering or some other non-search related job, right? So I will say with all the flexibility that we have right now, it is possible, right? But I cannot guarantee it works, right? Because the reason is that GINA is optimized for search, right? So we have to think about, we have thought through all the search patterns, all the neural search patterns from our experience, from our work experience in the past years, right? And so we have summarized a very good and very general design pattern behind all those neural search systems. And that actually makes GINA unique, right? And that makes GINA efficient and effective on neural search problem, but not necessarily on other problems. Right, so this is often so when people ask this kind of, can you use it for classification or whatever, right? So I believe we can, right? So because you can imagine GINA with all this flow API, you can imagine this is like Airflow or Kubeflow, right? But Airflow and Kubeflow, they are more like a general flow, this management system, right? Or orchestration things. But GINA is optimized, it's dedicated, it's tailored for search scenario. And so our company is called neural search company, right? So we only solve problems in the search domain, not in other domains, right? But of course you can, I mean, search is not a small domain. A lot of problems can be converted into search problems, such as question and answering, chatbot. So this seems like a traditional NLP problem, but you can also use information retrieval based method to solve QA and the chatbot things. Another example is the recommendation, right? We always say that recommendation is passive search, right? So the search is active search. You type something in the search system, so it's active. And recommendation is that you don't type anything into the search box, right? The content, the relevant content just come to you, right? Instead of you looking for them. So this is passive search, right? So I believe with some, let's say in the future, we might have some, plugins that somehow can convert the recommendation problem into the search problem. But again, this is under our radar, but it's not implemented in the near future. Right? Yeah.
I have a question.
Yeah, hi, Lucia. Yeah.
Hi. One more for the, let's say, general way of thinking. I know we had a lot of discussions around the hub and the core and kind of the moving forward, but more on the ideology, or maybe like your thoughts and feelings for everybody to hear and understand. In moving forward, I know we have to do some fixes on the hub, but what is your vision for core versus hub, and where would for different indexers, different crafters, like what is your general vision on the hub versus the core and the future of these two like product development from what comes in, like what were we gonna?
Yeah, so the reason that why we separate the core from the hub, or separate the hub from the core from the very beginning, is that we realize that chasing AI development is not a sustainable way for us as a company, right? Even when I work at Tencent AI Lab, and we spend a lot of time chasing the state-of-the-art AI development. But in the past 2 years, since BERT has come up, right? So there has been a lot of like a pre-trained model, right? All kinds of variants of BERT pop up from the community, from the academia, right? And you see the leaderboard keeps refreshing every day, right? It's not only natural language processing, but also like, for example, reading comprehension, computer vision, of course. And so for small company, for startup like us, chasing all the state-of-the-art AI development is pointless for us, right? And it's not our mission, right? And so in order, but we still want to keep ourselves, in the frontier, keep ourselves in the loop, right? We are, on top of in the top tier of AI engineering, right? So how can we do that? How can we manage the development in a sustainable way, right? So that nobody is burning out because of chasing all this development from the AI community. So we separate the hub so that basically my ideal case is that all the executor, right? All the executor, including the crafter, indexer, fast, Facebook fast, malwares from Zelis, and bird, all this kind of bird, Hugging Face, transformers, they should be put into the hub, right? And what left in the core is all those classic algorithms, right? Classic and basic operators, let's say search operators, right? And to make an analogy is, if you look at the TensorFlow, right? So TensorFlow also has this kind of, separation, right? So if you look at TensorFlow documentation, API, it's getting updated again. And so basically you see, so a lot of options. So TensorFlow has a very low level option. It's called tf.nn, right? So inside that, you do not find, all these names that you are familiar with, like CN, but you found some, some operators, neural network operators here, right? So like a L2 loss, right? This is a pretty low level, and pool, relu, this kind of thing. So with pool and relu, you cannot do anything, right? So with just this kind of operator, you cannot do anything, right? So you have to, use it as a building block and build up your own neural network, right? So this is, they keep this thing in the TensorFlow, so that makes sense. And then on top of that, we have, so what is the next one? The next one is probably TF Keras layers, right? So this is something that is, let's say, is a high level abstraction above tf.nn, right? And so in here, you already wrap they already wrap the primitive operators into this Keras layers, so that you can easily stack all these layers together, right? But you see that they already put that into Keras, right? So this is a different namespace compared to tf.nn, right? And eventually they have very high level thing called estimator, right? TF Keras estimator, right? So in this estimator, they say, okay, so they also have this tf.estimators, this one, right? So in this estimator, now you found a lot of very familiar names here, right? Like a DNN, linear combined classifier, and some like a CNN, whatever, this kind of thing, right? So here you found all these high level models, right? High level tools working with models, right? So in my understanding, right? So we need to put all these high level models into a separate namespace, and this is TF Hub. Sorry, this is GINA Hub, right? And so that so basically what left in the GINA core will be, for example, all the class that start with the base, right? So for example, the base image encoder, right? So all this base numeric encoder, base image encoder, this kind of thing. So all this class signature, they will be left inside GINA core, right? All the other things, all the inheritance from the, let's say from the numeric encoder, let's say what they inherit from the base image encoder, right? Okay, so right now we don't have, hardly it's not used in this way. So right, let's see base indexer, base indexer. Also we have base numpy indexer. Okay, so you see a lot of indexer are inherited from the base numpy indexer, right? So in my understanding, all of them, right, should be put into the hub rather than put into the core. So the reason is that first of all, it's much easier to maintain, and it's more sustainable in the long term, and also it's easier to manage the let's say the dependency, right? So we don't want to introduce a huge, very complicated dependency to GINA core, right? And so right now we keep GINA core dependency very, very simple and very, very restricted, right? So right now we only have this 5 or 6 dependency, right? NumPy, PyZMQ, protobuf, gRPC, YAML, and Tornado, right? That's it, right? So if we put a lot of models into core, then that means this extra requirement, this list will expand forever. And we are basically building a very fragile framework, which basically depends on a lot of things, right? So we want to decouple this dependency, right? And that's why we put all the state-of-the-art model into the hub, right? And so when people use hub, we expect that Docker, container, or containerization will be their first tool, right? It will be their, the hands-on tool when using the hub, image, right? And by using Docker container, right, all this dependency fixed in that image, right? So you don't need to worry about upgrading the version and so on, right? You don't need to do the CMake, build from scratch, this kind of thing, right? And the other reason is that so when there is a new model, right? So let's say if you want to contribute a new model or new algorithm to GINA, right? Do you go to GINA Hub or do you go to GINA Core? So what is the decision process here, right? So when I think about this problem, I always think that first of all, is this some algorithm that's just pop up in the last 5 years or last 6 years? Or is it something that is like TF-IDF, right? It's a pretty classic one that has been there for 30 years. And so if it is the first case, which means that this is still a very new algorithm, it's probably state of the art, but it's still very new, right? So then let's put it into the hub, right? The other case is that so let's say Google recently just released a new model like for computer vision, right, or for NLP. Then this definitely goes to the hub, right? Because when the academic first release some new models, usually they write this model in a very, let's say, not very productive way, right? So they write it for reproduce this purpose, or reproduce the result in the papers, right? So there are a lot of things that you can optimize in terms of the production, in terms of the engineering, right? So that's why if we really want to chase the AI development, so the frontier AI development, we chase that in the hub and we chase it with the community, right? Not only by us, right? And so this is the second thing. And the third example is that let's say I found a very unique package on GitHub, right? It's open source, but it's not maintained anymore, right? It is pretty classic, but it's not maintained, right? And they are the only package that can do this kind of algorithm, right? And in this case, we also put that into the hub, right? Because we cannot control the code quality because of nobody is maintaining this thing, or because of the they are using a very very restrictive license, open source license, like a GPL, right? This kind of thing, and we cannot. It's not compatible to Apache license, right? So so in this case, we put into the hub, right? And of course, we credit the original author with the correct license announcement, right? And so these are the these are my understanding of the core and the hub, right? And also the decision process between whether to put that into the core or put that into the hub. But that being said, so the hub, so some of you may realize that we stopped updating the hub repository for a couple of months. This is because we are still refactoring the infrastructure behind the hub, right? So you think about this, Hub also has some infrastructure, right? Like building the image, right? Like uploading the image and also maintain the image. And it's basically like a package management system, like PyPy or NPM, right? And so we are still looking at different solutions to whether to make it like a centralized package maintenance system, or we want to decentralize this thing, right? And still under discussion. Yeah.
Well, I actually wanted to ask something related to the hub, so it's good that Lucia already asked. Yeah. But then I just have one question more related to good practices. Mm-hmm. So I'm not sure I'm doing this right. What I want to ask is, I know that the flow can be done either with a YAML file or with a Python file. So yeah. I'm wondering if there is if it's better to do it in one way or the other. Yeah. I mean, I see that the YAML file is good because you don't have to touch the code, but yeah, I don't know. I just wanted to ask if that's a better way.
Yeah, very good question. So basically, you can imagine YAML file is just another interface for flow, right? So let's say if you interact Gina with a dashboard, right? Then the best way, it becomes very clear that the best way to interact with Gina is basically using YAML, right? On the dashboard, right? So because in this case, what you do is you basically use the dashboard to design your flow, and then generates YAML, and then sends this YAML file to Gina, right? And Gina passes YAML file and builds their flow, right? And of course, you can also implement all this REST API with add, join, implement all these flow operators and expose them using the REST API to the dashboard. But that's a huge engineering work, right? So the best and the easiest way to interact with Gina from outside is using let's say by outside I mean non-Python environment, right? It's using Java. It's using YAML. It's using YAML, right? And so this is one thing. The other thing is that of course we provide the Python API, Python Flow API. But let's say if you really look at it, right? So let's go to the Flow API. So if you really look at some of the examples that we are using the Flow, right? And so you will realize that the Flow API looks very powerful in Python, but eventually it only offers one method, right? Which is add. Right, which is add. So let's see if I can if I can quickly go to the add method. No, what is this pull request structure? Flow, and if you look at the method, right? So when you build the flow, right, the only method that you can use is add, right? So, so you can use, you keep adding, right? And you use needs this thing to to parallelize the flow, the pathways, to parallelize the flow, right? And so this is essentially the only API that you can use to build the flow, right? But this is not a real API, right? So if your flow object only support add, right? Then this basically is no different than reading from a YAML file line by line and then add to the flow, right? And so basically, if you think about, so for example, of course, there are some train index search, but this is after the flow is built, right? After the flow is built. So what I mean is when you build the flow, the only API that you have is add, right? So this is not, to be honest, this is not too powerful. Right? This is not too powerful. And the other thing that I recently add is needs. Right? So I add a needs API. So basically, this is previously called join. Right? I need to shut down this thing. Okay. So this needs API. It's basically previously I call it a join, but then you still can use join to do as a back compatibility. But here you see this is basically wait for multiple pathways and until before proceeding, right? Wait multiple pathways before proceeding, right? So this is another let's say another way to build another API that you can use to build the flow, right? But essentially we only have these two APIs, right? There's another way and no other ways to change the flow, right? And to be honest, this is not so powerful, right? So maybe in the future we can add more, but as you can see, so right, only if we have these two. We only have these two APIs, but you see that in our examples, right? In all the unit tests, in all our examples, they are already, let's say, powerful enough to represent all these examples, right? For example, all the use cases that we have, right? So let's say in the future, if we found that we need another operator, right? When building the flow, right? We can add to it. Yeah. So, but again, the best practice for you is that when building something, so when you try to, so let's say when you try to imagine you build a flow into a Docker image, right? And then this flow is not changeable anymore. It's immutable because Docker image is immutable, right? So code itself is not changeable anymore. So only thing that you can change is the config file, right? So you can configure your flow YAML file, you can configure your individual part YAML file, right? And so you can feed those YAML config file into as a bundle into the Docker image, into the Docker container, and run it, right? Without changing, without touching any code base. So this kind of strategy is very popular when we want to deploy something in production, right? So we don't want to touch the code base. We don't want to change the Docker image version just for, every time we change the flow, we will change some parameters, we need to update the whole flow to restart everything. And this is, let's say, this is prepared for that, for future purpose, especially for future purpose use case in production, right?
Yeah, okay, thanks.
Yeah. Okay, I see Deepanka has a question that why any reasons for selecting ZeroMQ over other message queues. To be honest, ZeroMQ is, I use ZeroMQ since Bird service, right? And it's pretty efficient. And I have very, let's say, deep dived into the ZeroMQ in terms of the documentation, in terms of the how the tech spec, like a tech specification and so on, right? And we think that this is pretty powerful, but it's not overwhelming, right? So sometimes you select a message queue which provides a lot of feature, but you actually don't need them, right? And ZeroMQ is less, I would say, is a tool with the right size, right, to solve this problem, right? And but if you look at our network layer, so we are not only use ZeroMQ, so we use ZeroMQ plus protobuf for representing the message, and then ZeroMQ for sending all these messages, for sending and receiving all this message. And in the recent version, I believe since 0.3. We actually use asynchronous mechanism and also use a ZeroMQ stream internally, right? So this greatly improves the efficiency of GINA, right? So all the P paths are now working in a very asynchronized and very non-blocking way, right? So this is pretty nice. And in terms of the public communication, so public communication means that if you consider the GINA flow as one entity, right? So how does GINA flow communicates with others, right? There we use gRPC, right? There we use gRPC as a communication protocol, and also the also REST, REST API as a communication protocol. But the reason why we choose 0MQ instead of REST API internally, but this I think is pretty obvious, because 0MQ stays on the TCP level, while REST API is on the HTTP level. It's one level higher than 0MQ, right? So it's, we want to do a lot of RPC, this kind of communication inside the PPAP, in between the PPAPs, right? But from the outside, we want to provide a nice general interface. So that's why we use gRPC and what is REST API, right? Yeah. By the way, so we also plan to have some kind of collaboration with 0MQ governance, open governance board, and so there is some progress there. So if you go to 0MQ website and scroll down, right, you'll see our logo here, Gina, along with Jupyter, right? And so that is something, right? Okay, so yeah, okay, so question, if we say P is a micro level and flow is a macro level, then what is the level of paths? What is the necessity of using paths? Okay, so path is basically wrapping multiple P's, right? The path provides a context manager for the P's, right? And so if you think about the scaling, right? And so let's say you want, so basically because each P is just doing the same work inside the pod, right? So let's say you want to start transformer, but start with 5 transformers, right? And so the easiest way is actually start with 5 Ps, right? And but who is redirecting, who is routing the network traffic to all these 5 transformers, right? If you start 5 Ps, right, independently, then who is managing their life cycle, right? Who is starting them? And you don't want to start them by yourself, right? And who is shutting down them, right? And who is routing the traffic to them, right? And receiving the traffic from them, right? And this is basically the relationship between P and path, right? So as basically I write it here. So if you look at 101, GINA 101, right? And so this little round guy is a P, right? So it is like for example the transformer or Facebook paths, right? And you can wrap multiple Facebook paths, right, into one part. So in this case, this part basically is a sharding management system, right? And if you can also wrap multiple transformers into the part. So then in this case, this is basically a parallel transformer. It's a parallel transformer, right? So in any case, this part basically is a context manager for the P, right? It does all the routing, does all the spawning and all the shutting down, right? And this is quite necessary, right? Yeah. All right. So are there any questions from the community? All right.
Sorry, yeah. A question from my side. Because
yeah,
GINA is like a neural search company, do we have any plans to add more like information retrieval based metrics into GINA to evaluate the performance of an like IR model or something like that?
Yes, very nice question. So basically, I believe so. There are two let's say design patterns that are missing in the current GINA implementation. Right. So one is train, the other is evaluate. Right. One is train, one is eval. Right. So this is basically very important, especially for the train. Right. And so without train, you can only think that GINA is a feed-forward procedure per process, right? So it's basically like a neural network that in the inference time, it's just a feed-forwarding, right? Without any back propagation, because it's not unnecessary, right? And so that's why but we already leave the train interface all over the place, right? We have the train interface inside the executor, right? And we have the train request inside the protobuf, right? So let's say the train, this design, this mode is already under a radar, right? But in terms of the evaluation, I believe it more or less like the train, right? So you can imagine evaluation is like a feed forward process for train request, right? You just feed forward everything, basically the data and your label all the way to the last p-part or to the last layer, right? And you compute the loss, right? You compute NDCG, you compute precision recall, right? And then you stay there, right? Well, the train request is like a two-way, right? It's a round trip, right? You feed forward your instance and label all the way back, all the way to the last layer. You compute your loss there, and then you are not stopping there, right? You back propagate all the errors, right? All the way to the sender, right? And I mean, all the way is kind of like a very casual term. Sometimes you want to fix all the other layers, but only optimizing the last layer, right? It's the same thing like in neural network. But when it comes to the challenge here is that when it comes to a microservice architecture like Gina, right? How do we want to back propagate all this gradient, right? All this error all the way back to the first microservice? Does that make sense, right? And is that scalable, feasible to do that, right? So this is some questions that we need to understand. But I believe evaluation, I already talked with Huang about this, the evaluation mode. I believe it's under our radar. I think it will be, I have to double check with Lucia and to check when this feature will be available. But let's say the evaluation mode is on our radar. And I would say the training mode comes after, right? Comes after the evaluation. Right?
Thank you. And actually, I got another, not really question, but suggestion. If you take a look at the the structure of Gina, there is a folder called clients. Can we? I was wondering, because clients, we only have a Python client here, but if in the future we want to add maybe Java clients, maybe Ruby clients, maybe even other programming languages, it's going to be difficult to maintain. Do you think it's good if we take out clients and maintain different clients into different repos in our organization?
So this is a very good question. So previously, there is another client, but probably so Sergi basically did. Okay, so I'll just mute you. Sergi previously built a Node.js client, right? But it's probably another repo in a different branch, right? So I remember that. And so we have so right now we have a Python client, we have a Node.js client, but we also have a Gina box. Gina box is like an end-to-end client, right? So you don't have to write any code anymore, right? So you just you still have to write code, but in HTML, right? But you're right. So this is a very good suggestion because it makes no sense to maintain Java client, for example, inside a Python package, right? And especially when you use Python to distribute it all this package, and people found out there is a Java file inside your Python package, and people will be very surprised and question about our professionality, right? So yes, good point. Yeah. So I mean, so right now we don't have many other clients, but it should be easy to build. Because we use gRPC as an interface to the outside, right? So we can have C client, we can have Java client, but also gRPC is not, let's say, it's not on the same level for all the language. Although it claims to be, universal, it speaks with different languages, But if you look at it closely, right? So for example, in the Node.js, in the JavaScript version of the gRPC, we realize that they haven't implemented the bi-direction streaming, right? So this is what we found out with Gina, with Sergi, like 2 months ago, right? So the JavaScript version of gRPC don't have bi-direction streaming, which is super important for us because you see the our gRPC, our GINA RPC is basically relies on bi-direction streaming, right? Request is a stream, and also it returns a request, right? And but anyway, so good point. Yeah.
That's clear. Thank you.
All right. So any other questions from the community? All right. So if there is no questions, then we can close today. And
I'm sorry, I got another question.
Yes.
Actually, I organized the examples with Yue today, and we as you asked, there are some different levels about there are different levels in GINA, but my question is the loader, flipper, or indexer some kind of thing are the pod or I mean, what's the definition of the pod?
Pod doesn't have any logic. Pod doesn't have any, let's say algorithmic level logic. So right, so it's basically just a scale or everything. It's just a context manager. So it doesn't. You cannot bound an executor into the pod. You can only bound an executor into the P, right? And so this is a major difference, right? So pod is just a shell. It's just a wrapper, all right, around the P. Right? So it's a context manager. It doesn't have executor. It doesn't have driver, right?
Okay, thank you.
Yeah. So basically, so as I said, so if you look at this cartoon, right, it looks a very stupid cartoon, but it's actually, you know, when I designed this thing, I put some thought into that. So you see this. So what is this gear guy? This gear guy is as I said, this gear guy is the executor, right? So they are from the executor family. This is a gear, right? And what is this car? What is this car? The car is its driver, right? So you see this gear and car drive into the P, right? So that means, so when you start with a P, it always starts with some gear, with some executor and driver, so that the P is functionable, right? So it's, you know, receiving the request, and you know, do some sophisticated processing, whether it is indexing, crafting, encoding, or whatever, right? So you see this little guy is driving inside towards the P, not towards the pod, right? So the pod is basically just a container of all the P's, right? I said it's a container because you can also run all the P's in one pod and inside a container, and you can run the pod remotely, right? So the pod, this pod is not a simple context manager, right? It can run, it can spawn all the P's locally. It can spawn all the P remotely. It can spawn all the P's remotely inside a container, right? And so it's very powerful context manager, right? But it is a context manager. It doesn't have any executor or driver, right? The real executor and driver are inside the P, not the pod, right? Yeah. So then what is the difference between, so let's say so for example, let's see this graph, right? So let's see this graph. Why are these two P's? Why there are two pods, right? And why don't you put one pod with 4 P's, right? The reason is that the P in the pod, the P in the same pod are homogeneous, right? So they behave exactly the same, right? And the pod is basically doing some routing, doing some load balancing, and to distribute the traffic into different P's. But from the individual P level, they behave exactly the same, right? But if we have two different parts, right? So they are from part to part, they are heterogeneous, right? So that means they behave differently when receiving a request, right? And so, for example, this part could be an encoder, could be a transformer, and this part could be another encoder, right? So there's a RNN, right, or whatever, LSTM, right? The traditional, all the old-fashioned, old-school neural network, right? And inside that, these are the two LSTM, right? These are the two LSTM, right? And these are the two transformers, right? So, so this is how I explain the the difference between PU and part. All right.